Hello everyone, and greetings from India. My name is Srinivas Kumar. I'm the Director of the Indian National Centre for Ocean Information Services of the Ministry of Earth Sciences, Government of India. I'm glad to be on this panel, making this presentation on INCOIS Marine Fishery Advisory Services as part of this workshop on Global Biochemical ARGO Fleet Knowledge to Action. INCOIS has a mandate to provide ocean information and advisory services to a wide range of stakeholders like the fishing community, coastal states, ports and harbors, etc. And to be able to generate and deliver these services, INCOIS does a lot of ocean observations through Insitu observational platforms. It has access to remote sensing, satellite-based observations, ocean modeling, and then the services span ecosystem-related services, disaster-related services, geospatial services, data-related services, etc. The service that we are going to talk about today is called the Potential Fishing Zone Advisory Services, or in short PFZ. This service helps fishermen in enhancing their fishing operations. Now, to know why such a service is important, we need to look at the Indian scenario of marine fisheries. So the Indian waters, being tropical waters, they are multi-species. There are several pelagic and demersal species, and the maximum sustainable yield estimated from the Indian EEZ, it ranges from about 4.4 to 5.3 million metric tons, and the current production is about 3.7 million metric tons. The point here is actually there is a lot more harvest that can be taken from the Indian waters while still maintaining the sustainability of fisheries. Coming to the fishing population, there are about 4 million marine fishermen with about 1.5 million of them engaged in fishing. And if you look at the fishing vessels, most of the fishing vessels, about 200,000 of the 270,000, they are either non-motorized or motorized non-mechanical, which means that they're mostly into subsistence fishing and done by artisanal fishermen. 70% of the catch comes from the west coast, which is more productive than the east coast. Now, what are the latest challenges in fishing? We all know that locating and catching fish is becoming more challenging as there is a lot of fishing pressure on the coastal areas. The coastal stocks dwindle and then move further offshore. And then if fishermen, traditional fishermen need to go offshore for fishing, it actually involves an increase in search time and associated increase in fuel cost, emissions, and human effort. Now, science-based short-term fishery forecasts have the capability to improve the situation. It can improve the economics of fishing operations and then manage stocks much better. And this is where INCOIS Marine Fishery Advisory Services, or more popularly called Potential Fishing Zone or PFZ advisories, come into play. Fishing communities have been fishing for generations, and then they have developed a mental model for making their decisions on where they should go and fish, what is the kind of fish that might be available, what is the quantity that might be available. So they have certain heritage. And some of the natural indicators that fishermen look at include congregation of birds, or color of the water, bubbles breaking on the surface of water, reflection in the night, or even a kind of smell. So these are the natural indicators that the fishermen use in finding or fishing for shoals. Due to the recent challenges in fishing that we've discussed before, there is a certain need for fishermen to have scientific guidance on where they can go and conduct fishing operations. Now, this is a scientific basis on this slide. So, fish have certain physiological, metabolic, and respiratory requirements, and then these requirements govern their presence in certain areas, which means that a type of fish, it actually depends on a certain habitat. And they also react to changes in surrounding environment, and fishes are always migrating either for feeding or breeding. And then they are found in places, they move to places where favorable conditions exist in terms of, say, temperature, salinity, dissolved oxygen, etc. Now, how do we identify areas that are actually conducive for such fish aggregation? Now, it's difficult to see large areas by human eye. So, naturally, what you look at is options like satellite remote sensing. But then fish schools cannot be seen directly from satellite altitude. So what we are trying to do is use indirect methods of monitoring selected parameters such as sea surface temperature, which is indicative of good physical environment, or chlorophyll A, which is a good indicator of food availability, wind, sea surface height, etc. From satellites. This is available at very high temporal and spatial scales. In addition, real-time Insitu and model-derived products on other ocean parameters, like for example, it could be dissolved oxygen, or nutrients, or currents, or mixed layer depths, etc., can also be used for operationally identifying PFCs. So in short, as scientists, this is what we are trying to find out. Now, what is the right niche for fish? And then this is actually defined by various physical, chemical, biological parameters in the seawater, like temperature, salinity, dissolved oxygen, currents, wind, nutrients, chlorophyll, light, and there could be many more. And as I mentioned, satellite remote sensing is a very good way to measure these parameters, and there are constellations of satellites that are actually meant for observing the oceans with several sensors. And then India, for example, has specific satellites for monitoring the oceans called OceanSat-1, OceanSat-2, which actually can provide information on sea surface temperature, ocean color, which is a proxy to chlorophyll, etc. Now, by processing the data from these constellation of ocean satellites, we could identify areas of upwelling or boundaries between two different water masses, eddies, fronds, etc., which can actually lead to fish aggregation. Now, these are some of the identification keys that are used to identify such habitats that are suitable for fish aggregation from satellite data sets. Further, as I already mentioned before, we have a suite of in situ observing platforms, starting right from the ARGO floats, the conventional ARGO floats and the BGC ARGO floats, drifters, XPTs, current meters, gliders, etc., which actually provide a lot of real-time information on ocean parameters. Specific to the ARGO program, INCOIS also runs the Indian ARGO program. It deploys about 50 ARGO floats per year in a ratio of 3:2 for the conventional TS and bio-ARGO floats. Since 2012, we have deployed about 62 BGC ARGO floats, which can measure DO, chlorophyll, backscattering, etc. And we also act as a regional ARGO data center in the Indian Ocean. And also the National Data Assembly Center. And as all of us know, ARGO floats have a wide range of applications, starting right from climate forecasting to ocean-atmosphere interactions to data assimilation into OGCMs operationally, and of course also understanding the marine ecosystems, including fisheries. What you're seeing on the right side top panel is the different locations of different networks of in situ platforms, starting right from ARGO floats to XPTs to drifters, etc., in the Indian Ocean region. INCOIS also runs a suite of high resolution coupled ocean ecosystem models in the regional scale, which are capable of simulating ocean features that lead to the PFCs. Now we use at a global level we use INCOIS GO-BGC, which is based around MOM model with a 3D VAR data assimilation system. And at a regional level in the Indian Ocean region, we use ROMS with LETKF data assimilation system, and the coastal high resolution models are built around ROMS again, also with biogeochemistry module. Now this helps with 3-day forecasts of PFCs to carry out the pelagic fishing activities, which requires multi-day fishing. So in a nutshell, these are the components of the PFC mission, where we have observing systems and models that we use, the products from which we use for operational generation of PFCs on a daily basis, and then these PFCs are disseminated to the fishermen in a very simple language, in a way that they can understand. They're disseminated in multilingual map and text formats, and then the fishing vessels use this information. They conduct fishing operations and provide feedback on the utility of this information, which actually gets fed back into the R&D efforts. And we also need to conduct a lot of user awareness campaigns as part of this mission, to ensure that fishermen understand the information that they're receiving, and then are aware of how that could be used. So this is an example of the PFC Advisory that is generated and disseminated from INCOIS. So as I mentioned, these are multilingual advisories for all coastal states, and then this is the map with the GIS map, which actually shows the landing center from which the fisherman goes out for fishing, and then the information in text form on the latitude, longitude of the fishing location, the distance, direction, angle that a fisherman has to navigate to reach these fishing locations. In addition to the standard PFC, we also provide species-specific PFCs. What you're seeing here is a species-specific advisory for tuna that is generated based on sea surface temperature, chlorophyll, and KD490, that is an index of the water clarity. And this service benefited from telemetry studies that INCOIS conducted in the North Indian Ocean on tuna. And along with these advisories, we also provide information on the maximum fishing depth based on SLA, sea level anomaly derived oxycline depth. It is not only important for us to tell where the fishermen should go for fishing, but we should also be able to tell them whether it is safe to go. Now, INCOIS has a major service called Ocean State Forecasting, where we run a suite of models to provide information on wave height and direction, swell height and direction, coastal currents, etc. Now, this information is also provided together with the PFC advisories to the fishermen, so that they know that it's safe to navigate to the fishing areas. We use a host of methods to reach this information out to the fishermen. It could range from SMS on a mobile phone to a app on the mobile phone, the TVs, FM radios, and to satellite broadcasting tools such as Gagan and Navig systems. Now, Gagan and Navig are very important because the fishermen can receive the information when they are out in the open ocean, outside the coverage of the standard mobile phone services. So we ensure that this information is reached to the fishermen in as many ways as possible, including INCOIS website. We also conduct a lot of awareness campaigns to fishermen, and we work a lot with the NGOs. Considering that there are about 9 languages that are spoken in the coastal states, we work with the NGOs to make sure that this information is customized to the local needs in their local languages. These are the examples of fishermen awareness campaigns that are conducted in the coastal harbors, explaining them on the use of this information how they need to receive, how they can receive this information, and then how they understand this information, and how they can put it to beneficial use. A lot of validation studies have been conducted on the utility of these information by independent research agencies and groups, and this impact of this kind of a service to the fishermen. It has positive impacts on the social, environmental, research and economic aspects. A lot of experiments have proved that the success rate of this information is about 80%, and they can have profits of 3 to 4 times, and then reduction in search time by 30 to 70%. Of course, these information results in a huge enhancement in the GDP from the marine fisheries. This is an example of a validation experiment where 2 boats were used. One boat going to the fishing location identified by the PFC, and the other one going away from the notified location. And then the information on the duration of the total trip, number of fishing hours, number of fishermen engaged, and the total catch was quantified to estimate the benefits of using this information. And obviously it has been noticed here that the boat fishing in the PFC location, which is identified as green, actually has spent less hours fishing and then made more profits, spent less fuel. So this is, and several such experiments have been conducted to come up with the estimation of benefits of these advisories. In addition to the economic benefits that we have discussed before, we found that these advisories lead to a huge environmental benefit. Now, there are several groups which have conducted these studies, and then found that, for example, one study found that about 32 fishing boats use this information in a particular district, in a province, and then they could save diesel of about 70,000 liters in a month. And this translates to lower carbon emissions by about 150,000 kilograms. So there are numerous such experiments which actually point to the fact that less search time means spending less diesel, and then less diesel means cutting down on carbon emissions. So the environmental benefits of these this kind of PFC service have been well documented. We also have come across numerous cases where the sustainability of fishing has been enhanced. This is a study where majority of fishers who have been practicing bottom trawling, which is much more detrimental to the fisheries and to the environment, they have converted and upgraded their fishing technique to gill netting, because now they know that there is scientific information that is available to them, and then they can actually take the risk of moving away from the coastal areas, conduct fishing operations, but then still return profitable. Now, this study shows that in one particular fishing village, about 50 of the 65 boats owned by 23 respondents have been converted from bottom trawling to gill netting, which is a much more sustainable fishing method. So that's on how the PFCs are generated, how it's disseminated to the fishing communities, and then what is the kind of benefit, both from the perspective of environment, from perspective of economics and sustainability, that accrue due to the use of this information. Now, PFC is one of the very mature applications of satellite remote sensing and in situ observations to common man. So now how did BGC ARGO, or how has BGC ARGO contributed to enhancing the science behind the PFCs? Now, I'll actually talk about a couple of examples. Like, for example, BGC ARGO can be used for monitoring the fish habitats. It can be used for identification of harmful algal blooms, and of course the BGC modeling. The data from the floats can be used for assimilation and validation. So I'll quickly run through a couple of these examples before I end my presentation. Now this is a study which highlights the use of BioArgo to understand the coupling of physical and biological processes, and then how it was this understanding was used for fisheries. So what you see here is the data from biogeochemical ARGO floats in the Bay of Bengal and Arabian Sea. And then the data shows that the thermocline and oxycline are tightly coupled. That's what you see on the right top panel. And then on the middle panel, you see that the sea level anomaly, which is actually parameter derived from the satellite data, it is actually inversely coupled with the thermocline. The low sea level anomaly has a shallower thermocline. A high sea level anomaly has a deeper thermocline. Now this also means that oxycline is also inversely related to the sea level anomaly, and that this correlation has been used to get information on the depth of low oxygen waters using satellite derived sea level anomaly. And then a couple of equations have been worked out that you see in the bottom of the panel, one for the Arabian Sea and one for the Bay of Bengal. Based on this knowledge, now these equations are being used now for operationally providing information on depth of low oxygen waters, which is being used for generating the tuna forecast. This information, it provides the third dimension to the tuna PFC advisories, that is the maximum hooking depth. Now the next example that I'm showing here is the identification of algal blooms from BGC ARGO data, where the parameters derived from BGC ARGO data, they clearly show the signature of the winter convective mixing, the temperature and salinity, and its association with the algal bloom, which is chlorophyll A, that is derived from the satellite data. So the combination of BGC ARGO, which actually is a signature of the biophysical processes, and satellite data, that is bloom species identification, can be effectively used to identify algal blooms, and then algal blooms have a direct impact on the fisheries. Now this is yet another example of how BGC ARGO data has been used to validate the performance of the model, the physical biogeochemical coupled model in the Bay of Bengal. Now we find that the model is capable of reproducing the observed temperature and salinity structures in the upper ocean, and it is also capable of simulating reasonably well the deep chlorophyll maxima as well as the oxygen minimum zones in the intermediate depths of the Bay of Bengal. Now such validation is extremely important for us to enhance the performance of these models, and eventually once we have a lot of BGC ARGO data that is available, we should be able to use this information, real-time information, assimilate into the models, and then get better forecasting capabilities. So this is another example of how BGC ARGO data is helpful. So I would actually like to end my talk here, and then just say that the information that we provide to the fishermen, which is actually called PFZ, is a very good example of how remote sensing data, in situ data can be used for benefiting the common fishermen, and then how BGC ARGO data has been useful in actually understanding the science behind what we do in terms of PFCs, and then why it is important to really keep enhancing the array, BGC array, similar to the standard ARGO array. We need to actually enhance the BGC ARGO array to be able to enhance our understanding of the ocean biogeochemistry, fisheries, and all other aspects. Thank you very much.